So welcome again. So I have a problem on recurrence relation involving a recurrence relation of degree 3 with specified initial conditions. So let's see how we solve this. So first step, let us assume an equals to r power n, where r is non-zero constant, is the solution. So I can call this one question 1, solution to question 1. By saying an equals to r raised power n, you mean that to define an minus 1, I'll require r raised power n minus 1. An minus 2 is r raised power n minus 2. And an minus 3 is r raised power n minus 3. Call this one equation 2. So what we do, we replace equation 2 in equation 1 to change the recurrent relation from A to R. So substituting 2 in 1, we get r power n is equals to minus 3 r power n minus 1 minus 3 r raised power n minus 2 minus r raised power n minus 3. That's what we get by that substitution. So then, because we have already specified that r is not 0, then we are allowed to divide through by r raised power n minus 3, n minus 3, n minus 3, n minus 3. So this is valid because r is a non-zero constant. So that will give us r power 3 equals to minus 3 r squared minus 3 r power 1, or just r, just r minus 1. And then we bring all the terms to the left-hand side. So we'll have r cubed plus 3r squared plus 3r minus 1 equals to 0. So for this given equation, which is cubic, so then we use this constant term to get the factors of this one. So constant term is -1, so factors are plus or minus 1. So we try to fix 1 in this equation. We'll have 1 cubed plus 3 times 1 squared plus 3 times 1 minus 1. So 1 plus 3 minus 1, this is not 0. So 1 will not work. If we put -1, so we'll have -1 cubed plus 3 times -1 squared plus 3 -1 minus 1. So this minus 1 plus 3 minus 3 and then minus 1. So remember the sign. So this is -1. So putting r for -1, so -1 power 3 plus -1 squared, and then so this not give us 1, but the first case, which is given by, now you see this sign must be plus, because when you shift from right hand side, the sign changes. So this sign must be plus. So this is plus. So that will work, that -1 plus 1 is 0, plus 3 minus 1 is 0. So this means that r equals to -1 is a solution to this given cubic equation. So by that, we mean r, take this to the left, plus 1 is a factor of the cubic polynomial r power 3 plus 3 r squared plus 3r, and then plus 1. Then we carry long division to get the other factors. So we write r plus 1, and then r cubed plus 3r squared plus 3r plus 1. So what do we multiply by r to get r cubed is r squared. So r cubed, r squared times 1 is r squared. Then you subtract. 3 minus 1 is 2. Bring these other terms, 3r plus 1. So we need to multiply 2r by r to get to r squared, so plus 2r. So 2r squared, 2r times 1 is 2r. Then you subtract again. 2r squared minus 2r squared is 0. 3r minus 2r is r. Then bring 1. So we need to multiply r by 1 to get r. So we say plus 1. Then 1 multiplied by this, we get 1 plus r plus 1. So difference is 0. So that means that the cubic equation r cubed plus 3r squared plus 3r plus 1 is the same as r plus 1 into r squared plus 2r plus 1. And this was equated to 0. Let's see how to factorize, or whether we can factorize this cubic, this quadratic part. So product is 1, sum is 2. So numbers are 1 and 1. So we'll have r squared plus r plus 1. So common is r in this first pair, r into r plus 1. Common here is 1 into r plus 1. So we'll have r plus 1 times another r plus 1. So which means that this cubic is r plus 1, r plus 1, r plus 1, which is 0. So these are case of a repeated root. So the value of r1, r2, r3, all of them are the same as -1. So this means that r1 is equals to r2 is equals to r3, and the answer is -1. So we can just call this one r. So the general solution will be given by a n is c1 r power n plus n plus c2n r raised power n plus c3 n squared r raised power n. This by definition, which is the same as an is c1 negative 1 power n plus c2 negative 1 power n plus c3 n squared negative 1 power n. Now what we do, we use the initial conditions given to find the particular solution or the specific values of C1, C2, and C3. So I've been given that A naught is given by 1. So this means we replace n for 0 in this general solution. So C1 negative 1 power 0 plus C2 times 0 negative 1 power 0 plus C3 0 squared negative 1 power 0. So this implies that C1 is 1 because this term will be 0, this term will be 0, and then negative 1 power 0 is 1. 1 times C1 is C1. So this is the value of C1. And A1 is given as negative 2. So that means C1 negative 1 power 1 plus C2 n is 1. C3. So that means that we'll have, so this will be negative C1 minus C2 minus C3 is minus 2, which implies dividing through by negative C1 plus C2 plus C3 is equals to 2. And since C1 is 1, then this means C2 plus C3 is 1. So call this one, say, equation 3. Then A2 is given as negative 1. So replace in the general equation n by positive 2. So C1 so that's what we have. So we'll have C1 plus, so 2C2 now plus 2 squared is 4. So 4C3 should give us negative 1. But C1 is given us from our solution here is 1. So that means 2C2 plus 4C3. So this is 1. So going to the right hand side will be negative. So negative 2. Dividing through by 2C2 plus 2C3 is negative 1. Call this one equation 4. So from this equation 3, C3 is given by 1 minus C2. So I replace this value in this equation. So equation 4 becomes C2 plus 2 into 1 minus C2 equals to negative 1. So C2 plus 2 minus 2C2 is equals to negative 1. So C2 minus 2C2 is minus C2 equals to minus 1 minus 2, which is minus 3. So C2 alone will be C2 divided through by negative, we get 3. And then C3, which is 1 minus C2, will be 1 minus 3, which is minus 2. So therefore, C1 is 1, C2 is 3, and C3 is negative 2. Hence, the particular solution is an, C1 is 1, so -1 raised power n, C2 plus 3 n, -1 power n, then C3 is -2, so -2 n squared, -1 this power n, which can be written as (1) plus 3n minus 2n squared, i.e. an is given by this, and then -1 raised power n. So that is a solution for that given recurrence relation. Thank you.